Alright, this is part 2 of our lesson on solving rational inequalities. So if you have not watched part 1 yet, you should do that first. If you did watch part 1, you should be able to do this problem by yourself. So pause the video and give it a shot. If you don't know how to do it, then put your pencil down. I'll show you how to do it, but then pick your pencil up and go back and still do it by yourself. Alright? Either way, the message is do it yourself. Normally, our first step on these problems is to get 0 on one side. But we already have 0 on one side, so we don't have to worry about that. I'm going to go ahead and factor this just so I can see what's going on, and we're going to need some of these factors later. So, of course, x squared minus 16 is the difference of two squares. So x plus 4 times x minus 4, and this trinomial is going to factor x times x, 5 times 1, negative, and positive. So nothing cancels out or anything. So it's time to go ahead and talk about the critical values. Critical values. Alright, the critical values are your zeros and your excluded values. So let's start with the zeros. Alright, the zeros of the function are going to come from the numerator, setting the numerator equal to 0. Because, you know, the denominator is not allowed to be 0. So the only way this function is going to ever equal 0 is if the numerator is 0. So we can just go straight to that. So if we set x squared, well, I started to say set x squared minus 16 equal to 0. But we already factored that down, so we can go with this numerator and set x plus 4 times x minus 4, set that equal to 0. And these will give us the zeros of the function. So, of course, setting this equal to 0 means setting the factors equal to 0. So x plus 4 equals 0, x minus 4 equals 0. So this is going to give me x equals negative 4. So that's a 0. And this is going to give me x equals positive 4. So those are the zeros of the function. Now, let's talk about excluded values. So we did the zeros. Now, excluded. Alright, the excluded values are the values that would cause a 0 denominator. So looking at this x minus 5, I know that x cannot equal positive 5. So that's an excluded value. Looking at the x plus 1, I know that x cannot equal negative 1. Okay, so all 4 of these values are critical values, and they will all 4 have to be used to help us break up our number line. So I'm going to get plenty of room over here to do this. So here comes our number line. I'm going to make it nice and long because we have a lot of critical values to test. Okay, so we have 4 critical values, man. Okay, so 1, 2, 3, 4. Okay, so my critical values, negative 4, negative 1, 4, and 5. So that's what I'm talking about. Okay, negative 4, negative 1, 4, and 5. These are my critical values. Now let's start with the zeros. See, what I'm asking myself now is, will these be open circles or closed circles in my number line graph? And actually, let's start with the excluded values, because the excluded values are always open circles. Okay, of course they are. they're excluded. In open circles, that's what we use to show that things are not included. So open circles at 5 and -1. Okay, so there'll be open circle here and an open circle there, because those are just straight up excluded values. Now, how about the zeros? Well, it depends on this. We want the values of the function. We want the x values that will give us values that are greater than or equal to 0. Now, the zeros of the function give us exactly 0 if we plug them in. So these will be included because we want it to be greater than or equal to 0. So equaling 0 is great. So we will include the +4 and the -4 by using closed circles there. So these values will be included. All right, now look at all these zones. We're going to have to use a test value in each one of these zones and check it out. Okay, so here we go. So in the first zone here, we need something smaller than -4. So how about -5? Something in between -4 and -1. I think I'll just use -2. Something in between -1 and 4. I'm going to use 0. Something between 4 and 5. Okay, I guess I'll go with 4.5. And something bigger than 5, so I'll go with 6. So I need to check each one of these values and see what's going on. Now, when I'm checking these values, I'm just going to use the original function. Okay, I'm going to use this to do my testing. So, and I'm going to use my TI-30XS multi-view. So, come to your calculator, hit the table function, clear out whatever's in there, and get to typing. Well, we got to go fraction mode first. Kabam. X squared minus 16 in the top. So x squared minus 16 over x squared minus 4x minus 5. X squared minus 4x minus 5. Okay. Now, I want to start at -5. So might as well. So -5. Okay, at -5 we have a value of 9/40ths. So we ask ourselves the question. Let's see. I'm gonna make this a little bit smaller. Is 9/40th, and we want values that are greater than or equal to 0. So is this greater than or equal to 0? That's the question. And yes, well, this is a positive number, so yeah, that's greater than 0. So yes. Alright, how about the value at -2? So I'm going to scroll down a bit. At -2, that's -12/7. Okay, so is -12/7 greater than or equal to 0? Well, no, that's a negative number. That's not greater than or equal to 0. Alright, how about at 0? At 0, the function is worth 16/5, 16/5. So is 16/5 greater than or equal to 0? Why, yes, it is. It's a positive number, so it is greater than 0. And next we need to check 4.5. Actually, I'm going to come back to that one because it's a decimal and stuff. I'm going to skip over to 6. Value at 6. Scroll down. 27ths. Okay, so is 27ths greater than or equal to 0? Why, yes it is. It's a positive number, and all positive numbers are greater than 0. Now I'm going to go back and check the value at 4.5. And I can do that easily by hitting the table function, hitting enter, and just typing in 4.5. Hit enter like 4 times. So at 4.5 we have a value of negative 17 elevenths. So is negative 17 elevenths greater than or equal to 0? Well, no. That's a negative number. That is less than 0, not greater than or equal to 0. So this is the information that we need. The yeses show us where the solutions are, and we will fill those in on the number line in fuchsia. The no's are not solutions, so we will leave those empty. So I have a yes in this zone. Negative 5 is a solution. That means all of these values are solutions. Okay, negative 2 is not a solution. Leave it blank. 0 is a solution. That means all of these values are solutions. 4.5 is not a solution. Leave it empty. 6 is a solution. So everything greater than 5 is a solution. So there is our wonderful graph. Now we need to sew this up with some interval notation. 1, 2, 3 parts. So starting with this part, it's coming in from negative infinity, and it's going all the way up to negative 4. Now see how that's a solid circle, a filled in dot? We're going to use a bracket to show that the negative 4 is included. And then union. And then here we have an interval from negative 1 to 4. So I'm going to put negative 1 with a round parenthesis. Notice the open circle. But then 4 will have the square bracket. Notice the closed circle. And then union. And I'm going to do 5 to positive infinity, because it just goes on from there. So round parenthesis, notice the open circle. So 5 to infinity. So there is your interval notation. Okay, so I'm just going to put a box around all this real quick while you're soaking in the beauty of my answers. Okay, so that is what we're talking about. The number line graph and interval notation. Okay, so that is the end of problem number 3. If you were just watching me do that, you need to go back and try to do the entire problem by yourself. Make sure that you can. Alright, this is the 4th and final problem of the lesson. Like I said before, we want to have a 0 on one side. So I'm going to subtract 7 from both sides, and I will get this. 7 over y plus 1 minus 7 is greater than 0. Alright, I just subtracted 7 from both sides. Now, I need to combine these into one fraction. So in order to subtract with fractions, you need like denominators. And you'll notice the left side has a y plus 1, and this 7 over here doesn't have anything. So I'm going to give it a y plus 1. Now I'm only allowed to do that if I do the same thing in the numerator. Okay, that means I'm not really changing anything. Also, whenever you have a subtraction happening, I recommend that you rewrite it as adding the opposite. That will remind you to do the distributive property, including the negative. Okay, so now that I have like denominators, I can go ahead and put this together. So I will keep my like denominator of y plus 1, but I'll have 7, and then I'm distributing here. So this is going to be negative 7y minus 7, not plus 7. That's a common mistake. Alright, that's why I put the negative up here to help you remember to do that. Now, notice here I have a 7 and a negative 7. Those are just going to cancel each other out. Okay, because they're opposites. So that's going to leave me with negative 7y over y plus 1. Not too shabby. And no, I cannot cancel out these y's. This is connected by addition. Leave it alone. So that's as simplified as we can get. Once you get 0 on one side and you simplify as much as you can, it's time to start looking for our excluded values. Wait, did I say excluded values? I meant critical values. Critical values. Right? When I talk about critical values, I'm talking about the zeros of the function and the excluded values. Let's start with the zeros of the function. Alright, the zeros of a rational function will come from setting the numerator equal to 0. Okay, because the denominator is not allowed to be 0. So the only way this fraction is going to equal 0 is if the numerator is 0. So we will set negative 7y equal to 0. And of course, I'm going to wind up dividing both sides by negative 7. And that's just going to give me y is equal to 0. Okay, so that is the 0 of the function. Okay, now, how now, brown cow? Is that really the 0 of the function? Yeah, let's just go with that. So y equals 0 is the 0 of the function. Now, I need to find the excluded values. Excluded. Alright, the excluded values, you know, if I look around the original problem or any step in the problem, I see that y is not allowed to be negative 1 because that would cause a 0 denominator. So y cannot equal negative 1. Okay, so I've got my 0 and I've got my excluded value. These two values are going to break up my number line for me. So let's get that going up here. Okay, so here comes the number line. Kabam. Okay, it's not very straight, but I'm not going to worry about it. So I have negative 1 and 0. Okay, so I'm just going to spread them out a lot because I have a lot of room. Negative 1 and 0. So next we have to decide, will these be open circles or closed circles? Well, let's start with the excluded values. Excluded values are always open circles because they're excluded, and open circles show that a value is excluded. So negative 1, whoop, too far. Negative 1 is an excluded value, so let's definitely show that with an open circle. Now, how about the 0 of the function? Well, that depends on whether we want 0 or not. We want values that are greater than 0, not equal to 0. And zeros give you equal to 0. So we don't want that. So we're going to leave this an open circle as well. Now, we need test values in each one of these zones that we have created. Test values. So we have these zones like this. So in this zone to the left, less than negative 1, for example, negative 2. Now between negative 1 and 0 is all decimals, so I'm going to go ahead and do negative 0.5. And then bigger than 0, I'm going to just go ahead and do 1, because why not? Alright, so I'm going to evaluate the function at each of these values, but to do that, I am going to use this version of the function right here. Okay, negative 7, over negative 7y over y plus 1. To the multi-view, hit the table button. Okay, go into fraction mode. Negative 7y. Okay, so negative 7. Well, we've only got x's, so we'll have to make do. Over y plus 1. So that'll be over x plus 1. Okay, enter. Now we want to know what's going on at negative 2. So let's start at negative 2. Okay, at negative 2, the function has a value of negative 14. Okay, so the question is negative 14, and we want values that are greater than 0. So is negative 14 greater than 0? Obviously the answer is no. Negative numbers are not greater than 0. Let's skip over this decimal for a minute and look at 1. Okay, so if I scroll down a tiny bit, at 1, the function has a value of negative 7 over 2. So the question is negative 7 over 2 greater than 0? Same question. Again, this is negative, so no, it's not greater than 0. Okay, I didn't check the negative 0.5 yet. So hit the table button again, hit enter again, and type in what you want. So I wanted negative 0.5. Oh, I put 0.05 by mistake. I'm messing up today, people. Let me start over. Negative 0.5. Okay. At negative 0.5, the value of the function is 7. So the question is 7 greater than 0? And of course the answer to that is yes, it is. Alright, the yes tells me where the solutions are. So since negative 0.5 is a solution, then all the values in this zone are solutions. So I will show that by filling in a segment here. Now the no's show us where the values are not solutions. So negative 2 is not a solution, so none of these values are solutions, so I leave them blank. Same thing with 1. So this is the graph right here. That's it. Okay, let's just write it in interval notation. Now this is going to look like an ordered pair, but in this context it's an interval-like domain. So I'm just going to put negative 1 comma 0, meaning the interval from negative 1 to 0. We show that it's not including the endpoints by leaving round parentheses. Okay, and that's it. So we'll put a box around it. Okay, that's the answer to number 4. And that was the last problem. So I really hope that this video was helpful to you. Again, if you were just watching me do that whole problem, go ahead and pause the video and go back and redo the problem by yourself, just to make sure you can do it on your own. Do it on scratch paper or something. Alright, I will see you guys on the next video. Check me out.